just go.
Yeah, I'll start the introduction.
Okay.
Hello and good morning, everyone. Welcome back again to the Pinelands speaker series. Today, we're very fortunate to have Rick Lathrop with us. He's a scientist that works for the Center for Remote Sensing, and I'll probably say this wrong, spiral or spectral analysis. Does a lot with GIS, and he's got some really powerful tools. And he's going to talk with us today about a program they've developed called New Jersey Forest Adapt. And with that, I'm going to turn the program over to Rick.
Okay, Joel, thanks for the invitation to speak as part of this series. I've had a long association with the Pinelands Commission, so it's nice to be able to share some more recent work. So let me get this going. Okay, so there's a lot of interest in resiliency, and especially in terms of climate resiliency. And the state of New Jersey, has recently released this past spring in April, their climate change toolkit. And so I want to talk about some of the work that we've been engaged in at Rutgers, thinking about this and coming up with tools and information. And this talk is really about the idea of a place-based information. How can we think about what's happening at particular locations across the state, and how we can use that to inform decisions and policy and management. So, I guess I'm obliged to talk a little bit about, in terms of some of the climate science and some of the tools. How do we know what we know? And some of this is based on models, global models that look at how, as the atmospheric concentration, the greenhouse gas emissions change, how is that changing our climate? And so, that's looking at past observations of temperature, and then when we think about into the future, well, now we have to use models, and these global climate models predict a continued warming of our climate. As we go further and further out in time, you can see the envelope, the uncertainty around those predictions increase. And then depending on what happens with our greenhouse gas emissions, if we manage to reduce them, well, then we can lower that future temperature change. If we don't, then we, continue to increase greatly. But what I want to talk about is, well, what does this potentially mean? That's kind of the global scale. What does it mean for New Jersey, and how does this relate to the Pinelands? So this is some work by David Robinson, and you can see this is almost 10 years old. And so we've known, about climate change for a number of years, and people have been thinking about what the implications are for this state. And so, this Dave, back in 2013, gave this presentation about, the idea of, increasing temperature. When it comes to precipitation, there's a bit more uncertainty in terms of whether it's going to increase or stay the same. But one of the key things is increasing variability in both temperature and rainfall, and storms and flood and drought, as well as rising sea level. And I think last week, Vanessa Tropiano talked about that. So we know that some things with reasonable certainty, but there's also a lot of uncertainty in terms of just the magnitude of the change and the seasonality and some of the extremes. So that was kind of global scale, kind of bringing it down, in terms of a little bit of crystal ball, what might happen to New Jersey. When it comes to actual management, a lot of times people are saying, well, what does it actually mean for my county or, potentially my municipality? So some of these models, there's the global scale, and it was called the downscaled. And so actually looking at these, mapping the results, and then downscaling those to states and counties and the like. Now, these are some maps. Oh, let me go back here. Maps of showing in terms of, historical, in terms of temperature, This is mean daily maximum temperature, and then looking at this projected into the future. So one thing, first off, recognize that these are coarse scales projections, okay? And there is a certain uncertainty, and to reflect some of that uncertainty, there's, in terms of these different scenarios, these RCP, this representative concentration pathways, and so as part of our tools, we try to show some of this uncertainty depending on the different RCP in terms of 4.5, whether we actually do a moderate attempt at reducing greenhouse gases versus kind of business as usual, which is more of the 8.5. And so we have been trying to provide this kind of map information as part of a series of tools, and so which we have called NJForestAdapt. And so one of the first tools we built, this was started back in 2010, is NJ Flood Mapper, and that was looking at sea level rise. And then since then, we've worked more on thinking about some of the other aspects of climate, things like precipitation and temperature and the like. And so it was gratifying to see, as part of the broader New Jersey and the DEP strategy, and in terms of resilient NJ, some of the tools that we have developed, there was a shout out by the DEP that these are available, in terms of NJForestAdapt, and I'll talk a little about our municipal snapshots at the lake. And the idea is that's why we built these tools, to help decision makers across the state at various levels of government and also non-government, down to the local scale, as well as individual citizens, to have the best available information about what we know about how the climate might change in the future. So thinking about forests, what are the implications for forests? And so a few years back, assembled a team at Rutgers, the Center for Remote Sensing and Spatial Analysis, the Office of Research Analytics, the Rutgers Climate Institute, and the Center for Resilient Landscapes. And so that's the kind of internal Rutgers team, but there's been a number of outside collaborators. At the Northeast Regional Climate Center, they're the ones providing the climate data. Our colleagues at the New Jersey Parks and Forestry, the Northern Institute of Applied Climate Science, as well as the U.S. Forest Service. And we're continuing to expand this list of collaborators. So what are we trying to do here? One, our goal is to promote climate resilient forests across New Jersey, as well as the broader Northeast US region. And so part of this is the tool that we're developing is a WebGIS portal to enhance access to, again, kind of place-based information. So different kinds of maps, as well as other information on the state of New Jersey's forests. So some of that is present day, and then also projecting into the future. We're trying to bring together map data from a diversity of credible and authoritative sources. So it's not necessarily that we're creating all these data, we're trying to pull data from the Forest Service and other places and bring it together. And so New Jersey folks can have access to it, and providing links to other kinds of information resources to promote adaptation strategies and various case studies. And then again, we try to provide access to the original data sources, but also synthesize takeaway information in a variety of formats. So the NJForestAdapt tool is broken out into these variety of different themes, climate, other kinds of climate associated risks, and then information about the status of our forests today, a little bit working with the U.S. Forest Climate Change Atlas to project in the future, and then just information about our forests, some of the stats, land use, land cover, forest cover, some of the risks. And so I'll give you a brief tour of that today. So we try to incorporate in the NJForestAdapt, I'll show some of the maps, but other kinds of information in terms of how you might use this information in terms of tips. How might it inform tree planting and forest management? And so some of this is thinking about climate, but also climate metrics or parameters that actually relate to how plants grow. Okay. And for instance, one of those is growing degree days. And so, you know, again, the way the maps look, here's New Jersey with an overlay, but we include, these are regional data sets. And again, these are coarse, but this is the best available information that we have at this point, you know, based on these downscaled models. And again, for providing historical perspective, you can see this is data synthesized over 30 years from 81 to 2010. And then projected, again, these different concentration pathways, and then projecting it out into the future. And so, you know, in the near term to the longer term, and then also change versus not just what we think the growing degree days might be in the future based on these different scenarios, but what the change is versus the present day, or in terms of this historical baseline. So why growing degree days? Well, that's an estimate of the length of the growing season, okay? And so it's based off of temperature. And so basically, you know, in terms of the number of days above this kind of reference temperature of 50 degrees. And it provides, you know, in terms of different plant growth needs, but also pest cycles as well. Pollination, scheduling, fruit harvest, and the like. And so again, it's trying to bring climate down to information that might be relevant to decisions related to whether it could be agricultural crops or trees. And again, this information provides likelihood of different species composition, competitive success, as well as possible pest risk. Other aspects, for instance, heat, okay, you know, in terms of heat zones. And so this is another way. So this is looking at more of the extreme heat. And heat zones look at the number of days basically above 86 degrees. So we had that heat few days, you know, high 80s, 90s, just the other week. And, you know, I could really see the difference in terms of how plants responded. You could see they start to wilt, because in terms of their physiology, they can't basically, it changes some of their physiology, can't photosynthesize as well, even if they have enough moisture, you know, in some cases. And so checking heat zone maps, you know, in terms of comparing present day versus potential in the future, could help in terms of forest management planning, in terms of anticipating what species might suffer versus other species might be able to better tolerate the heat. And so might see a change over time. So for instance, you know, Eastern white pine, which were kind of, you know, in terms of more towards the southern range of their growth range, they start to suffer at higher heat, as well as some of our other kind of northern species. So you might also be interested more in terms of land surface temperature. This is actually satellite data looking at in terms of the temperature of the Earth's surface itself. So this is not a model, this is observation from satellite. That was at a coarse scale, this is at a finer scale. And this is of interest when people really want to think about urban forestry and try to figure out where are the hot areas, and basically, you know, what you're seeing here is the difference between the amount of impervious developed surface, which is the kind of the really red urban areas, and areas that have more tree cover are the cooler areas. And some of our urban areas where there are greater tree cover are cooler. And so thinking about, well, where those areas of planting trees might help reduce some of this heat stress and lower some of the land surface temperature. Now, I wanted to just give a little bit of an aside. This is some work by a graduate student, Katie Russell at Rutgers, but this was in collaboration with Dr. Mike Gallagher at the Forest Service at the Silas Little Experiment Station, and Julia Brennan, who's an undergraduate student. And this is about ticks and looking at forest thinning and land surface temperature. So this is some work. Katie did this as part of a class this past summer, and this is ongoing work that Julia and the like are. But we were interested in saying, okay, well, how could we use, potentially some of this remote sensing data to look at a core scale what's happening in terms of the land surface temperature. And Julia's doing much more detailed studies, on these areas as well. But when we look at the Pinelands, we actually see that there's actually quite a difference in land surface temperature depending on the types of trees, and you can see some of the in this case, the riparian zones where you might cedar or maple swamps. And then what they were interested in is areas that had been thinned versus unthinned. And so we can see that there is this thermal signature, and what they're studying is how that's actually affecting the tick populations and the ability of, because ticks are sensitive to potential heat stress. And so that's work that's ongoing right now in the Pinelands. And the jury is still out. They're collecting data, and we'll learn more about the results. But it is interesting to look at based on the remotely sensed imagery and the difference. This is basically showing difference across a growing season between the thinned versus unthinned stand. And during the summertime, you actually have several degree difference out there in the forest. Another thing, as part of the NJForestAdapt is, a lot of people are interested is, wow, what's going to happen to our trees? And this map is showing a hemlock. So we have, you can look at, present day, current day, and then we break this out by species groups and some of the common species that we might expect in New Jersey. And so we don't see hemlocks in the Pinelands. This is more in kind of the northern part of the state, but they're an important, basically evergreen component of our forests. And you can see we're at the southern end of their growth range. And so, and then looking at future climate change, this is 80 years hence at RCP 8.5. And so the colors, the diminish, the graying of colors shows that their importance value in our forests is expected to decline. So still expect some hemlocks, but much fewer hemlocks over the next 100 years if climate continues to warm as it's going at this present rate. And then this is just showing the change in that. So the deeper reds, the greater the change in that, and in this case, a loss. Now, there's losers. Hemlock expect to be a loser, but there's also ones that are gain. And so this is showing loblolly pine. This is the present day distribution, and loblolly just kind of basically almost makes it up, and makes it into, southern New Jersey. And under future climate change, you can see in terms of the kind of growth niche expected to increase across the state. And so potentially loblolly could increase. Now, you got to there's a distinction between in terms of, not saying that loblolly is going to grow all this way across New Jersey. It's got to get there. It's got to disperse. But this in terms of the conditions that loblolly seem to favor will increase across the state. And so as part of NJForestAdapt, we incorporate some work done by the Forest Service where they've done a number of climate change projections for individual tree species. This is for the coastal plain and just those species, in terms of potentially winners and losers. And again, part of this information is if you're going to plant a tree, think about that future climate and what tree species, you got to plan for the future, because you want that tree to live for the next 100 or more years. And so you want to think about what the climate might it see as it matures. And so again, these are just some common species we have across the state, and in terms of projected increase versus holding steady versus decrease. And so this is information. Again, we're taking, trying to connect credible, authoritative information from a variety of surfaces, places into one spot. We have some information, in terms of our county level forest statistics, and we're working to enhance that. But in some cases, that's our limit, in terms of things about growing stocks and mortality and stand age and the like. But this is showing in terms of oak pine. And again, you can see how, there's the pinelands and our oak pine forests. But you might be interested in looking at forests from other perspectives. This is looking at cover, forest canopy cover. So from 100% down to zero. So how dense, or what's the percentage canopy cover? And again, this is some work done by the Forest Service. And then in this case, this is just looking at, the different forest types from, and so, we look at the pinelands and, in terms of the amount of coniferous, and basically it's just mapped into 3 categories: coniferous, mixed deciduous, coniferous, and then deciduous, as well as, those are different canopy closures again, and whether it's forest or scrub shrub. Now, one of the areas is in terms of pest risk, and this is present day. We don't have projections yet, some thoughts on how pests might increase or certain species, but this is in terms of present day risks to our forests. And this is one that I live up here in Somerset County, and that we're experiencing is the emerald ash borer here, which is affecting our ash. And so pretty much wiping out ash in large areas in our forests where it does occur. As we go further south, you're concerned with other species. And so, for example, southern pine beetle. And so this maps in terms of, projected basal area loss. This is kind of the one way we measure in terms of, with the amount of, basically it's just based on the circumference of the trees. And so it's not predicting 100% basal loss, but, in terms of significant in some places. And then wildfire hazard. And this is, again, this is present day. There's different models out there. So we incorporate several different data sets. This is one produced by the state, but then the U.S. Forest Service, as part of their land fire program, has other information. No matter, which data set you look at, you can see that, basically, the pine barrens, we all know, has got, a fire dependent ecosystem, and wildfires are a really important component in that system. And we get fires every year. And you can see, very high fuel loads across that. It varies, across the uplands. And then again, you can see the riparian areas, which are much lower in terms of some of these fuel risks. And then another phenomenon that we've been looking at in terms of related to climate change is what we call, coastal forest dieback. And I think Vanessa Tropiano talked about this last week. And so this is really at the edge of the Pinelands. And sometimes this is referred to as ghost forests, as sea level rise. It is affecting those coastal forests that due to a couple different actually processes. We just recently summarized some of the literature on this and produced a report that was just released this past December. We've got a fact sheet on this as well, but it's a combination of changing groundwater tables that are actually raising in relationship to sea level rise and almost drowning some of these coastal forests, as well as saltwater inundation due to storm surge and king tides and the like. So it's kind of like a 1-2 punch. And so we expect this to continue to increase and move further inland. And it really varies from place to place. And again, that's why place-based decision, depending on the slope, there's some places we expect greater change versus other places less so. And so again, you can see that, the Mullica area as one of those areas, as well as Delaware Bayshore and the like, that we expect change over the next 50 years. We have links to other kinds of resources out there. Again, U.S. Forest Service, the iTree system. There's a lot of good tools out there. People really starting to think about forest and forest adaptation and trying to get the information as well as the tools that people can use to make decisions. As well as we assemble or compile different case studies in terms of what people are doing across the state, as well as across the region, bringing those out there. And again, giving access to the original data sources and the like. One of the resources I wanted to highlight is the Mid-Atlantic Forest Ecosystem Vulnerability Assessment. And so this was a synthesis that was published back in 2018. And they also have a adaptation workbook. And we have worked with this Patricia Butler Leopold a year ago on a kind of webinar. COVID shut down. We were to hold some in-place workshops. Maybe that'll be something that will be a possibility over the next, in the coming years. In terms of, she comes in and actually works with local, could be local governments or NGOs on working through this kind of, they call it the workbook, to think about that. And the tools, part of the NJForestAdapt tool is to provide some of the information that can then be used in this through this workbook to inform that. One of the we've tried to do is, okay, like, yeah, you want to look at the maps, but a lot of times people are then interested in thinking about this in other ways and thinking about their area. And so we've created a whole series of what we call municipal forest snapshots. And so this is some work that we did with also New Jersey Parks and Forestry in terms of working with them as end users, what kinds of information with the groups that they work with do those groups need. And so how could we mine this data set and produce it in a format that would inform them in their kind of municipal decision making. And so that we have these municipal snapshots for every municipality across the state to kind of give the state of the forest in their locale. And then we've expanded this municipal snapshots to incorporate a lot of other aspects in terms of climate. Some of this also, again, relates to coastal resiliency and the like. And we'll continue to expand this, thinking about other health aspects and the like. And then also you might be interested in downloading a map and sharing that map. And so we have ways that you can collect and share maps, based on what you see on NJForestAdapt. So I wanted to now segue into some work that we're doing right now with the New Jersey Climate Change Alliance and their Natural and Working Lands Forest Work Group. And they're interested in thinking about how forest management can fit into a broader strategy of increasing carbon sequestration. And some of this is in response to the New Jersey's 80/50 report, again, thinking about the carbon, kind of carbon gain. How can we plants, as they photosynthesize, are taking carbon out of the atmosphere, storing that in woody materials. And so, it's a way, potential pathway to remove or sequester carbon. And then the state, the New Jersey Parks and Forestry, is about to release their action plan. I think it's going through final review and approvals. And so that's something that should be coming out either later this summer or this fall. But in working with the Natural Lands working group, they're really interested in thinking about, well, how much carbon, where's carbon in terms of forests, the role in terms of storing carbon. And so this is a map from ForestAdapt, but it's based on work done by the Forest Service that looks at carbon and the amount of carbon stored and different compartments. This is showing total forest carbon, but we think about, how much is above ground, how much, how much is below ground in roots, understory, standing dead, down and dead. So there's a number of different compartments, and you can see variability across the states as well as within our state, based on the type of forests and the terrain and the soils. So as part of ForestAdapt, we're also, again, developing additional outreach material that we on the tips and resources to help people think about some strategies for using forests and trees to manage carbon. And so this idea of, good forest management is good carbon management. And so how can we keep forests as forests? Okay, keeping our forests around. And then how can we keep those trees and forests healthy in terms of what are some of the good management and stewardship practices, and to mitigate the risk of existing forests, trees and forests to become carbon emitters, sources of carbon instead of the sink of carbon, different ways of thinking about planting trees, afforestation, and utilizing wood products to keep carbon stored. So kind of some terminology you might have heard, just this idea of carbon defense, keeping the carbon that we have in forests, protecting carbon storage and sequestration. And then carbon offense is like, how can we actually go out and think about securing new carbon storage and sequestration? And some of that relates to, afforestation, areas that aren't forested, planting trees, planting forests. So, some of those is, there's this effort as part of this broader New Jersey Forest Action Plan, in terms of thinking about how to plant trees, increase our forest area, and what's appropriate in different places in terms of appropriate place, time, type. And again, thinking about that future climate, thinking about the type as well as methods. And then again, from the carbon defense strategy, thinking about our forests today, but again, with an eye towards the future. And how can we protect those forests, into the future, ensuring, natural succession and species composition are adapted to future climate conditions. And some of this is thinking about, trying to maintain a diversity of forest structure and composition. And so if a pest comes in, emerald ash borer is a perfect example, is we could expect certain pests. If all our forests were ash trees, we'd be in a hard pressed situation. But our, at least central New Jersey forests are relatively diverse. So if we do lose one tree, hopefully we can make up, tree species, we can make up it for with others. And so again, thinking from a forest carbon perspective, we know that as forests grow, they store carbon, they store it in their above ground, they store it in their below ground, they store it in the soils. But disturbance can come through and what was a sink can now be a source of carbon in terms of carbon release. And so depending on the type and severity of that disturbance, forests can re-emit carbon. And this partly, this is a natural cycle, but it's something that we should be cognizant of. So one of the ways that foresters use as a carbon defense strategy is silviculture. Is thinking about growing culture in terms of growing trees, growing forests. And so one is that how, again, carbon defense, how can we protect against insects and disease outbreaks? Some of this potentially through managing density. Thinning forests can potentially help, and that's found to be useful in terms of helping manage southern pine beetle outbreaks, potentially reducing forest density and ladder fuels to protect against wildfires, canopy burns that really come in and are more destructive in terms of the actual existing biomass as compared to a cooler ground fire. And again, promoting a diversity of forest composition and age and structural classes. Potentially could promote greater biodiversity and habitat sustainability across the broader landscape. Now, when it comes to climate and carbon considerations, again, thinking about, this is proactive management we're talking about in some cases. Some cases maybe let it alone. Other cases, we're actually proactively managing to think about, again, future climate change, suggesting we're going to have more and intense storms, things like Sandy, where there was a lot of wind throw in some places, depending where your forest, in terms of potentially more intense wildfire seasons, again, the more frequent and violent storms. So this is going to be a huge challenge for all our forests, but especially, in terms of the pinelands. Now, the pinelands, pitch pine is such a pivotal key species, and it's really a case study in resiliency. These are some photos. This is a photo by Pinelands Commission's own Giant Bonnell, looking at from the Apple Pie Hill, and fire towering. You see a sea of pines. Where you get canopy burns, you can see how it burns out the forest, but pitch pines are incredibly resilient. They're some of the most resilient in terms of individual tree species, the way that they can resprout through epicormic branching and the like, and seeding in after a fire. So in some cases, Pinelands is actually really blessed to have this incredibly resilient species already there. And in the middle of its kind of growing region, we're a little bit at the southern edge. And so as you go further south, you do start to see some of the other southern pine species, again, like for instance, that loblolly pine. But they are also, similarly adapted, maybe not quite to the same extent as pitch pine. So how do we balance the central role of fire in the pinelands ecology with other goals of carbon sequestration? And this is where I see the challenge. Wildfires, pivotal role in maintaining the pinelands as pine lands in terms of maintaining pine, but you also have wildfires' role in releasing stored carbon back out to the atmosphere. And so, the question is, how can prescribed fire or thinning fit into this equation? I don't have the answers to that. This is active research by a number of people about the Pinelands, all the great work being done at the Pinelands Research Station, the Forest Service, thinking about fire's role and as well as the New Jersey Forest Fire Service. So again, a challenge because in some cases, we can let forests grow and they'll continue to store carbon as long as there's no, major disturbance or pests. When it comes to the pinelands, that disturbance is part of the system, and so it's there's no one-all prescription for all forests. Again, that's why it's place-based information becomes so important. And then carbon isn't the only thing. we grow trees and forests for a lot of other benefits in terms of water quality and habitat and the like. And also, it's not just forests in the countryside, trees and forests occur in the city as well. And so there's a lot of interest on trees in our urban environment and all the benefits that they provide in terms of stormwater management, air quality, energy savings. I show you that land surface temperature. And so in closing, we've developed this tool. It's continuing to grow and evolve as we get input from various end users. And so we welcome your feedback today, but also into the future. This has been supported by the New Jersey Agricultural Experiment Station and the USDA McIntyre Stennis Program. And again, a shout out to all the collaborators that we're working with and continue to work with to continue this tool, because again, this is a challenge. Climate change isn't going away, and as we learn more, hopefully we will continue this tool to continue to evolve to provide New Jersey citizens and government agencies and non-government organizations and the like, the best information that we know that's out there to help them think about climate. And again, that goal of promoting climate resilient forests in our state. So with that, I close, and I'm going to hand this, I guess, back to Joel, to if there's field any calls we might have or questions.
Rick, thank you very much. That was a really neat presentation. It's great to see all that data and all those data sources, and then figure out a way to make them available, but also available in a way that people can visualize, and then to take it a step further as you did, which now we understand what's going on, how we can project it into the future and plan for what's going to happen. So that's really neat to make those tools available to the public and the people who are making the decisions, the municipalities, the different counties, all that. Thank you very much for highlighting these tools and just touching the surface about what they can be used for, and how important it is going to be to plan for our future, for our forests and our towns, and to try to balance everything out. Very good.
Thanks, Joel.
As Rick said, now would be the time. If you have a question, please feel free to call in. This was kind of neat. It's very timely. The commission has a climate committee, and these are some of the very topics that they're grappling and thinking about and trying to figure out what's the best way to move forward, what are the best resources to use. And this is really vital information in that regard.
Like I mentioned, that's so what we're working on now related to the natural lands and working group is based on some of the questions that they've had, actually some kind of targeted analyses to provide them information. So it's kind of like, okay, well, how can we mine the information that we have, the data sources that are out there, to provide them information to help them moving forward. And yeah, as part of the New Jersey, the Rutgers University, Land Grant University is kind of part of our, we see as part of our role, providing that kind of outreach.
Yeah, there's so much data out there, but to be able to use it as like a filter to filter out reliable data, credible data, and then it's just so much more powerful once you have it, it's vetted, and then you can really start to utilize it. And that's one of the other things I saw that touched upon me is how unique these sources are, because there's one thing to have information, but you really need to understand that information, and that's what the ForestAdapt really is going to enable the users to do.
Still work in progress. We're trying to build that out, but it provides a good platform to build from.
And This program will be available on the Commission's YouTube channel for future reference. So if someone is there or here and can't call now, you can always, Rick had his email up. You could always email him to follow up with anything specific. And I'm sure he's more than happy to help you and talk to you about just the impact or the power of all the spatial analysis that they're doing through Rutgers University and the partners is really going to be important as we plan and prepare for our future. We'll give it we have a good 30-second delay on us, so we'll give it a little while, another minute or so, just to see if any folks have some questions out there.
Okay, fair enough.
It was pretty interesting to see the pine beetle data specifically, to see where the losses could be or where they could be in the future. And that's a clear sign that things are starting to change. They definitely, the warmer winters, the less cold it gets, the less longer the periods of cold, the better chance those beetles are going to have to survive. And we can definitely see where they've had an impact. We can see where through planning, through fitting, like I said, and some other operations the Forest Service was able to take, how we were able to kind of stem the tide. And then the weather cooperated a little bit. We did have a couple years where we had some colder weather, but that was a few years ago. It may be swinging back the other way, but that's just a really great localized example of how this information can be so powerful. We'll just give it a little more time. In my mind, it seems like it's going long, but it's not as fast as I think. So we'll just give it a minute and see if anybody has any pertinent questions. It's kind of like the old adage, a watch pot never boils.
Again, people just Google NJForestAdapt. It'll get you to the site, or just NJAdapt, and you can access the whole suite of other tools that NJ Flood Mapper and some of the other NJAdapt tools.
Another interesting thought I thought about during your program is along the last year, we've had David Robinson has spoke to us. Inga Lopuma has spoke to us about some of her work. We had Vanessa last week, and we've had a lot of these similar programs about all these people that are working together on this problem. So it's pretty neat to see that there is a great effort being put forth, and there is hope for the future. It's not just a negative thing. Like you said before, there's winners, there's losers, and there's going to be better ways to adapt. And I think that's a really important thing to focus on. Because there are challenges, of course, but we're going to be able to meet the challenges if we all work together.
I mean, that's the key thing. Our forests are resilient, and having a mix of species, each with kind of different life histories, different climate ranges. It's not all or one. That there will be some winners, and there will be some losers, unfortunately. But change, it's going to be expect change. And so what we're trying to do is in terms of how can we adapt to that change.
All right. Yep. Very well put. On that note, I will wrap up the live broadcast, and we'll be back. We're going to take a week off or so. We'll be back in July with another round of programs. And coming up on July 15th, We're about to start registration for the next summer Pineland short course, which is going to be July 15th. We're going to partner with Stockton University. It's going to be held at White Spog Village and also at Wells Mills County Park in Ocean County. So that's our next big venture, is the Pineland Summer Short Course for 2021. It's going to be pretty much an all outdoor event that's going to be socially distanced, and we're going to be able to spend some time in the bogs, the swamps, and the woods and learn about the Pinelands. So that's what we're going to be up to. And with that, we'll see you guys all out there. Have a great day.